with Sarwat Ahmed. Be sure to like the video and subscribe. It really helps the channel to grow. There is another question of electrochemistry, so let's start. State relationship between Faraday constant F and the charge on the electron E and Avogadro number. So this relationship is F is equal to LE, where L is the Avogadro constant and E is the electron. So draw the diagram. If the charge on the electron of the AR and the valency of copper are known, the value of the Avogadro number can be determined experimentally. This is done by passing a known current for a known time through a copper electrolysis cell and weighing the mass of copper deposited onto the cathode. Draw the diagram. Suitable apparatus for carrying out this experiment. Label the following power supply with positive and negative terminals, anode, cathode, and ammeter. State the composition of the electrolyte. So this is the power pack. Positive terminal, negative, positive, negative, positive. This will be negative terminal and this is positive. So this is anode. If it is connected with positive, this is known as anode, or this is cathode. Electrolyte is copper 2 sulfate solution, CuSO4 aqueous, and we place ammeter over here. Ammeter. And this is power pack, or power supply, you can say. The following are the results obtained from one such experiment. Current passing through is 0.500 ampere. Time current was passed through cell is equal to 30 minutes. Initial mass of copper cathode is 52.243 gram, and final mass of copper cathode is this. So moles of copper will be, by subtracting this value, mole of copper. First calculate mole of copper is equal to 52.542 minus 52.243 divided by 63.5. That is equal to 4.71 into 10 raised by 2 minus 3 mole. Moles of electron in the equation is, you know that anode equation is Cu solid to form Cu2 positive plus 2 electron, and cathode reaction is Cu2 positive 2 electron to form copper solid. So we know that there are 2 moles of electrons. So moles of electron needed, moles of electrons needed is equal to, so over here 4.71. So if 2 moles of electrons will be there, then 2 into 4.17 into 10 raised by 2 minus 3, which is equal to 9.42 into 10 raised by 2 minus 3 mole. So we know that this relationship Q is equal to amount of charge is equal to which into IT, where I is the ampere and T is the time. We have 0.5 ampere passing through, so Q is equal to IT. So this is first step, this is second step, this is third step. Q is equal to IT, and we know QI जो है is 0.5, time is 30 minute, so 30 into 60, which is equal to 9000 Faraday. So the number of electron, this is fourth step, just over here, number of electrons passed is equal to 9 coulomb, not 900 coulomb, 900 over, we know that F is equal to LE, so L is equal to F over E. So 1 Faraday is equal to 900 coulomb divided by 1.6 into 10 raised power to minus 19, which is equal to 5.625 into 10 raised power 21, and number of electrons per mole is equal to, so this is number of electrons is equal to per mole is equal to is equal to 5.625 into 10 raised power to 21 divided by number of electrons per mole. This is 9.42 into 10 raised power to minus 3, which is equal to 5.97 into 10 raised power to 23, which is approximately 6.02 into 10 raised power to 23. So L is 6.02 into 10 raised power 23 is the L value. So first calculate the number of moles, then anode cathode reaction. We know that the 2 moles of electrons are produced, and number of moles of electron needed is equal to 2 into 4.7. This is moles of electrons required. So we know that Q is equal to IT, and QI ampere is 0.5 into 30 minute into 60, so this will be equal to 900 coulomb. And we know that the number of electrons passed is equal to 900 coulomb, and F is equal to LE. This is the relationship, and L, we know that L is equal to F over E, or in this way we calculate 900 over 1.6 into 10 raised power to the F is equal to 900 coulomb over 1.6 into 10 raised power to 19, which is equal to this. Now we know number of electrons per mole. We have calculated above 9.42 into 10 raised per 2 minus 3. Now this is equal to 5.625 into 10 raised per 21 divided by 9.42, which is equal to 6.02 into 10 raised per 23. Hope you will understand this question. The substance formed at the anode at the cathode when gaseous solution of the following compounds are the compound silver. This is the when aqueous solution. Aqueous solution is concentrated. The product at the cathode is silver and fluorine gas. Iron 2 sulfate, oxygen gas at anode and hydrogen at cathode. Magnesium bromide, bromine gas at anode and hydrogen gas at cathode. Because hydrogen is above them, so hydrogen discharge at the cathode, hydrogen gas. There is another question of electrolysis from the October-November 2010 paper 4.1. The electrolytic purification of copper can be carried out in apparatus similar to the one shown below. The impure copper anode contains small quantities of metallic nickel, zinc, silver together with inert oxides and carbon resulting from the initial reduction of copper or with coke. The copper goes into the solution at the anode, but the silver remains as the metal and falls to the bottom as part of the anode sludge. The zinc also dissolves. Write half equation including state symbol for the reaction copper at the anode. So anode is the impure copper which dissolves in the solution and form copper ion 2 positive. So this is the reaction, copper solid dissolves to form copper 2 positive plus 2 electron. Use data from the data booklet to explain why silver remains as the metal. So from the data booklet, silver positive to silver solid cell is equal to 0.80. So it is easily oxidized because it is more positive. It is easily oxidized as it is more positive, so silver remains metal, in the solution. So it is more positive or it is less positive, so that's why copper solid dissolves in the solution and silver not. Use data from the data booklet to predict what happens to the nickel at the anode. E cell of nickel is 0.25. Nickel is readily oxidized. Nickel is readily oxidized as it is less positive than copper. Write half equation including state symbols for the main reaction at the cathode. Copper ions discharge at the cathode after gaining 2 electrons to form copper solid. Use data from the data booklet to explain why zinc is not deposited on the cathode. Zinc cell is E cell is minus 0.76. It is more negative. so not easily reduced. Suggest why the blue color of the electrolyte slowly fades as the electrolysis proceeds. The blue color fades because copper ions are being replaced by zinc ions. Most of the current passed through the cell is used to dissolve the copper at the anode and precipitates pure copper onto the cathode. However, a small proportion of it is wasted in dissolving the impurities at the anode, which then remains in a solution. When a current 20 ampere was passed through the cell for 10 hours, it was found that 25 gram of pure copper was deposited on the cathode. Calculate the following using appropriate data from the data booklet. Number of moles of electron, Cu, mass is to 225 copper, mole of copper 225 divided by mass 6 AR 63.5, which is equal to 3.54. Number of moles of electrons needed, 2 moles are required, so number of moles of electrons needed to produce this copper is 2 into 3.54, which is equal to 7.08. Number of moles of electron that pass through the cell, number of coulomb is equal to Q is equal to IT, which is 20 into time 10 seconds, 60 into 60. This is equal to 7.2 into 10 raised to 5 coulomb. Number of electrons is equal to 7.2 into 10 raised to 5 divided by 9.65 into 10 raised to 4, or 96,500, or which is equal to 7.461. So percent of current is equal to 7.461 minus 7.087 is equal to 0.373 divided by 7.461 into 100, which is equal to 5.01. Nickel often occurs in ores along with iron. After the nickel reduction of the ore with coke, a nickel iron alloy is formed. Use data from the data booklet to explain why nickel can be purified by a simple electrolysis technique to that used for copper using an impure nickel anode, a pure nickel cathode, and nickel sulfate as the electrolyte. Explain what would happen to the iron during this process. Because iron is more reactive, is more negative value of the E cell than nickels, so the iron will dissolve or oxidize earlier than nickel. So nickel from the data booklet, solid aqueous is equal to minus 0.25, iron to positive iron is equal to 0.44, and so these are the E cell of the nickel, and electrode nickel aqueous solid nickel reduced oxidized form of E cell of this is electrode potential value of nickel, and this is electrode potential of 0.44. This is more negative, iron is more negative, is more negative. E cell of iron is more negative than nickel, so the iron will dissolve or oxidize.